Get Certified Together program is created by Technocofe, your free online knowledge sharing website, based out in London.
Processing unit so that they can perform their day-to-day work, they can run their day-to-day softwares. When you're deploying your application on top of a server, you need a processing power on that server. Some of the key providers like Intel and ARM, they provide these processors, and you have a hell lot of options to choose what kind of processor you want, what kind of hardware you want to deploy on your data center, on top of which then ultimately you will be deploying your application. Hey everyone, welcome to another episode of Get Certified Together series. This is episode number 32 I am recording today. We have already covered domain 1 and domain 2, so big congratulations to all of us. We are pretty much clear about cloud basic of cloud security, cloud infrastructure security, different type of cloud deployment models, cloud service models. We are having a good idea now about data lifecycle as well, how we can make sure that our data is secured, our information is always with us, no one takes it from us. And just related to that, I got one mail just last day from my Google account that one of my password is hacked. They were not sure about which one, so they sent a list of password which might be insecure, and they just mentioned that there is a potential leak happening somewhere on the internet, and there is a chance that one of your account was in that list as well. So you make sure that you change your password. And this reminds us again related to the same thing: security, cloud security, information which we are securing onto the cloud, whether it's secure or not, accounts which we are creating randomly, all those single sign-ons, all those using our Gmail ID to just register anywhere, just using the cookies and making sure everything is public, and we are just going through on and on, trusting someone with our own personal information. And this is something which is really scary in a way, but it's part of life. We have to do it these days. And back in India, we have a saying that your safety is on your own hands. It's not like if you are using AWS or if you are using some application, if you are using some cloud services, then you can simply rely on them. It's not like that. You have to make sure that you are using secure password, you are regularly changing your passwords, you are regularly making sure that the password is complex enough. It's not simply your name or combination of your names. So there can be an n number of scenario where your information can be leaked outside. And cloud security, cloud information security is a key thing now, is a big topic now, because most of the information, most of the data is stored on the cloud. Most of the applications which we are using on our phone, on our laptops, is actually hosted onto the cloud in backend. All in all, you have to make sure that you are doing your bit. You have to ensure if you are deploying that application, that you have to ensure that you are using that application, you are deploying that application in a secure manner. If you are from the cloud service provider side, you have to make sure that you are providing a secure infrastructure to your end users. So everyone have to play their part to make sure that everything is secure, everything is always updated and always in the right hands. On personal front, I didn't record anything last week because there was summer break again for the kids in the school, and of course if my kid is at home, then I cannot record anything, I cannot do anything innovative. So only thing I did was I just prepared for the next week episode, which is today. And it was pretty easier for me this time because, like I told you last time, that what will be going on from now is cloud infrastructure security. And I am from the cloud infra background as well, and it was kind of like a cakewalk for me. I immediately finished 3 or 4 topics and I was so eager to share everything with you guys. But I know if you are not from the same background, then it can be a bit overwhelming. So I'm not covering everything, but for sure it was easier for me to prepare this week's episode because most of the things I have either already covered in the chapter 1 where we covered cloud infrastructure basic. Most of things are already covered there as well. And for me, because I'm working in that field, so it was easier for me to grasp those topics and grasp the information and share it with you. As we go on, we will be covering that cloud information security from now onward, from today's weeks onward. What else we did last week? I went to Kew Garden. If you are not from England, if you've never been here, then Kew Garden is a place inside London city itself. There's a big garden. I was not really sure how good it might be because back in Singapore you already have a lot of gardens, so it's not kind of thing which you really feel excited about. But when we went there, it was actually pretty good. They have maintained it really well. It was kind of like a different place even in within the London city itself, when you have so many buildings and everything is crowded, everything is, a lot of people are there. But when you go to that place, it's quite open, lot of greenery, lot of flowers, and because of the summer and springtime, it was kind of like we felt it was the best time to visit that place. Although later only we came to know that in winter they put a lot of lights and a lot of decorations there, so it's a good place to visit in winters as well. So maybe probably we'll go in winter as well. But yeah, it was a nice visit that time. I am learning a lot of things. I am facing a lot of challenges in my existing day-to-day project work, and I felt that I should be sharing some information in some kind of way to everyone. So probably not here, but in some another way, probably a YouTube video I'll make soon, or maybe I'll write a blog on my website technocoffee.com to just make you guys aware what kind of things, what kind of challenges I am getting these days in my cloud deployments and cloud day-to-day work, because those things are bit longer and they have a lot of information. I don't want to share it here in the same episode because otherwise it will be kind of messy. First I'm discussing about my cloud operational issues and then I'm straight away moving towards cloud security. Those things are not really the same. We have to make sure that those things are covered in a different episode. So either I can make an episode in the same podcast series, or I can create a completely different thing as well. I am just thinking over, I'm just noting down, I'm just accumulating as much information as I can, because I really don't want to put in effort of creating a YouTube video only for a single topic. So it's better if I have lot to offer, then only it makes sense to create kind of a YouTube series with few of the challenges which I'm facing and which might be helpful for someone who is doing the similar kind of deployment in their setup. So something similar I am thinking over these days, and if something comes up then for sure I will let you guys know. And today is AWS Summit in London. I was supposed to be there. I am not going there because I have work at home, and sometimes you have to just decide what's your priority. And for me, priority was to stay at home and take care of my kid. That's what I'm doing today. I was not going there, part of that AWS Summit. I think Platform Con is also starting today. It is a remote conference, so I can of course attend that for another 2 days. But yeah, I really wish to go AWS Summit this time because it's happening in the same city where I'm living in, and of course it's good to go there to learn what's new coming up in AWS and what happened in the last weekend. The big heartbreaking news for me personally and all the United fans out there, we lost in the final against the rivals Manchester City, and it was kind of bit upsetting. I kind of knew that we had a tough chance against a strong team, but of course you always hope for positive, and that's what I thought. Maybe a bit of luck here and there and we can really pull it off. But in the end it happened like what was expected, although I'm a bit happy with the score line. It's just 2-1, so it's not worse than that. When you are having such a strong team in your opposition, believe me, United had their fair share of bad defeats in the past 2 or 3 years. So this result, although we lost, but it was kind of close. 2-1 is absolutely fine. There were some moments where we really felt that we might have a chance of coming back from behind and maybe take it all the way to the extra time or maybe to penalty shootout. It didn't happen, but yeah, of course, hoping something better in the next season. But I really wished that we would have stopped Manchester City from winning treble. If you are not aware, then treble is a scenario where a team wins 3 trophies in a single season. City now have won 2 already, and next, I think this week itself they have, or maybe next week they have their final game of the season. If they win that game as well, they will be having 3 trophies. Only United have done that in the past in English Premier League, and that's kind of another upsetting thing for me as well, because I really don't want someone to take away the record which only United holds. But like Beckham mentioned in one of the interview, it's really not about like who is winning in the next time, because you will find down the line after decades someone someday is gonna win the treble again, and it's not something United can stop themselves. But there can always be only one team which did it for the first time, and which is United. So something to cheer about. We did it for the first time. Alright, I think I talked a lot about personal random stuff, and I think it's good time to move into our main topic, main discussion today, cloud infrastructure security. Before moving to today's topic, let's have a quick break. Alright, like I said, Today we are covering chapter 3. We are starting with cloud infrastructure building blocks. If you recall, we already covered that in part 1, in chapter 1, but it's part of the syllabus. And ultimately, like I said, I think I clearly recall I told you guys I told before in during chapter 1 as well that cloud infrastructure building block is a key component if you're trying to understand security, because if you don't know what you're securing, how you're going to secure that? So I think that's the only reason they are bringing it again in chapter 3, but it's okay. Means I don't have any issue with it because it's actually kind of a repetiting thing for us. So let's start with today's topics, and first is cloud infra block. What are the 3 basic cloud infrastructure building blocks? Compute, storage, and networking. So we can start today again with those 3 things. First, let me start with compute. Now, compute is nothing but processing power. Processing power is what? Your normal CPUs. So if you want to run some application, it will need some core, it will need some processing unit so that they can perform their day-to-day work, they can run their day-to-day softwares. When you're deploying your application on top of a server, you need a processing power on that server. Some of the key providers like Intel and ARM, they provide these processors, and you have a hell lot of options to choose what kind of processor you want, what kind of hardware you want to deploy on your data center, on top of which then ultimately you will be deploying your application. So compute is kind of like a key critical building block, and without compute or an under provision compute can lead to your application not performing as expected. And in case of cloud, when we talk about all this scalability, all this elasticity, those big terminologies, we need high compute power, we really need high-tech latest softwares, we really need high-tech latest processors. Only then those big heavy application can perform their day-to-day work. If you are storing your information, if you are running sort of like a data analytics model onto your cloud system, onto your servers, they must be having processing power to really run those model, to really do those day-to-day analytics. And that's why it's really important that you dimension your hardware, you dimension your computes properly. Only then your application will not have any kind of lagging, they will not be facing any kind of issue while installing new things or while updating your application which you're deploying onto your server. For networking bit, it's pretty straightforward as well. Everything should be connected. You are accessing those applications, you are accessing anything which is running on the cloud from where? From your laptop. How it's reaching your laptop? From the internet. So setup which is there on the cloud should somehow be reachable all the way from internet to your laptop. How you can make sure that is happening? You have to lay in all those cables. You have to make sure that there is a network switch, network routers there in the place, connected to your servers, so that information which is onto the server, application which is running on those server, can connect back to internet, can connect back to your laptop, your home system, your office premise network. Anywhere it should be going via networking setup. And those router, those switches should be having enough capacity, because like I told, applications are getting heavier these days. With heavy application, you need better compute power. If there is heavy application, compute power is more, the data size is also increasing. It's not like if we are watching YouTube video, we can watch it in those old 240 kbps kind of thing. Now everyone is running these 4K videos, 8K videos, HDRs. They are heavy data which need to be transferred from point A to point B. How it's coming from, for example, YouTube server to your laptop? It is coming via some kind of pipeline, some kind of fiber network is already in place on those YouTube data center, coming all the way from internet to your laptop. And those fiber, those cables are connected to some kind of switches, some kind of routers. So those routers, switches should be having enough capacity, they should be having enough port bandwidth so they can allow this big heavy information transfer from point A to point B. So we have to make sure that we have good high spec networking equipments as well. IP address allocation is one of the key critical thing in the cloud, because now everything is onto the cloud. You are set up anything, even in the traditional data center or those traditional on-premise setup or private IT cloud as well, IP address allocation is a must to have, because what you really don't want is 2 people or 2 machines using the same IP addresses. You really have to make sure that everyone is allocated a unique block, everyone is having a unique IP address with him, and that you can make sure by using a proper kind of IP address allocation management system. Those IPAM systems will make sure that IP associated or IP allocated to any machine or any device or any system will not be reallocated to another system onto the network. So you can easily track who is using which IP schema, who is using which CIDR block, and make sure that there is no overlapping anywhere onto your whole network. Otherwise, it's really gonna spoil the runtime of application. If two applications started using the same IP address, it's really gonna make everything a mess. So IP address allocation or IPAM management system are a key to have, one of the key infrastructure component when we're discussing about this networking building block of the cloud. And we are, of course, like in traditional data center network, we in cloud as well, we are using a lot of networking protocols, OSPF, BGP, IBGP, EBGP, a lot of things are coming. And if you are not from networking background, maybe you shouldn't care about them. But if you are from networking side, then you know the importance of these protocols, importance of choosing the right protocol when you are deciding network communication between two devices. Again, cloud may be a fancy term, but it's just another name of a data center. It's just another fancy name of the setup which you used to run on-prem. So even though you are using cloud, you have to make sure that all those networking protocols are also being considered when you're setting up anything onto the cloud. You cannot just randomly go there and think that cloud is only about creating an EC2 instance. It's not as simple as that. You have to think over a lot of things related to networking, related to computes, and of course, the next point related to storage. So storage is another thing which we covered before, if you recall, about object and block storage. Both are really important. Both are having a different use cases. Object, if you recall, is something which you store in kind of like a whole file itself or whole document, whole images itself onto the cloud. You dump it on a data lake or on a backend cloud provided system. Those files will be accessible to you using HTTP or REST APIs, and you can fetch them from whenever you want, from wherever you want. Block storage, on the other hand, is kind of like a traditional disk which we have on our laptops or which we used to have on our servers. Those disks which are storing information in kind of blocks, and those block storage are mostly used kind of like a backend operating system root disk, which we can assign to our instances, assign to our virtual machines, or assign to our containers, so that they can run their application, run their softwares onto that root disk. Different cloud service provider provide their own kind of block storage system as well. But again, storage is one of the key components, just like compute and networking. Now, these three building blocks are always there, irrespective of we are setting up on a private cloud, on-prem, or on a public cloud, or on a hybrid system. We need to consider about these three. The next bit which I am talking about is only for the private IT cloud, which is the physical infrastructure. If you are setting up a private cloud, you have to start with setting up a data center. Now, data center is nothing but a place where you keep all the servers, all your physical devices in a one place. Those servers will be stacked in a rack. You can have one U unit or two U unit based on the kind of server which you are having. And those servers then will be requiring some kind of cooling as well. They will be requiring redundancy in power. So you have to install two power modules, kind of like active standby, in case one power module goes down, secondary power module takes over, so that your rack or your servers are always up and running. Same goes for cooling unit as well. You have to make sure that there is an active and standby cooling unit, because if data center temperature rises, it can malfunction your servers. Your server may go down, or they can heat up and they can auto shut down as well. So data center, of course, begin with this basic layout planning, that we need to plan out where we are putting it, our rack. We have to plan out our power system. We have to plan out our air conditioning, cooling devices, everything. Once that setup is there in place, we have a data center location planned, and we need a standby location for the whole data center as well, right? What if there is a physical impact, or there is a physical kind of hazard? What if there is a kind of like a physical calamity? Maybe there is an earthquake, or maybe there is a fire in your place where you put your data center A, site A location. You have to create a site B as well, exact replica of the site A. So you have to set up a DR site for your data center with everything exactly same. Now it's your call. If you're a big organization, you can afford to run both data center in parallel. You can of course run it. If you are smaller organization, maybe you just set up that site B location, but don't power it on. Leave it as it is, just in case. If something goes wrong with site A, you power on the site B, and it will of course be time consuming. It might not be a kind of active solution or active and hot standby solution, but it's still better than not having anything for your business continuity. So this is again indirectly related to business continuity planning, which we also covered in one of the subtopic in, I think it was in chapter 1 as well. So if you think over, everything is kind of related, everything is slowly coming back what we covered in chapter 1. So for business continuity planning, we need site A and site B of the physical data center. And last bit, which is again applicable for anything onto the cloud, is virtualization. Now, virtualization, we have covered it again and again. Virtualization is nothing but the key technology which enables us to use cloud system. If you are running an application onto a single physical server, you're kind of not using the full capacity of that server. You are deploying one application on one server, second application on second server, kind of like wasting the resources. With virtualization, you can easily use same physical hardware, same physical server to run 3 or 4 applications together. And that's kind of like the thing which we want if you want to save money, right? We want to run multiple applications together, because remember, all those applications may not be using 100% of the resources always. Even if you check your laptop, you go and check the current utilization of your laptop. Although you are running it, you are using it, it will show that you are 50% utilized, or your RAM is 4 GB utilized out of 8 GB. You are using 50 or 40% of the resources which your laptop have. So you are kind of like wasting that other 50% bit. Your laptop have a lot of capacity, but the application, your Google Chrome, your other things which you are running on the laptop, they are not using everything at every time. You are kind of wasting the resources. But in case of laptop, it's absolutely fine. It's your device. You can do whatever way you want. But if you are investing a lot of money, if you are investing thousands and thousands of dollars in buying a physical server, you really want to use it 100%. You really don't want it to be always consuming, 10 or 20% of utilization and just wasting the resource. And to make sure that you're running more and more applications together on the same physical device, you need virtualization. Now, how virtualization can be achieved? Using hypervisor. Hypervisor is a software which we run on that physical hardware that ensure that your physical hardware then can support multiple applications. So it's kind of that tiny piece of puzzle which when you install on your physical server suddenly gets the power of supporting multiple applications. And that's what we want. We want to achieve kind of like multi-application support from our physical hardware, from our physical servers. So hypervisor makes sure that we achieve that. Hypervisors can be of two types, type 1 and type 2. Type 1 installed directly on your physical server. So on your physical server, when it boots up, it have a kernel, it have initial boot module and everything. And then straight away it have an hypervisor. So it's pretty simple. On bare metal, you install a hypervisor and voila, that bare metal can now support multiple applications. In case of type 2 hypervisors, we first need an operating system on top of your bare metal. So in top of your server, on top of your bare metal hardware, we first install a normal operating system. Maybe we can install Ubuntu, we can install RHEL, Red Hat Linux, or Alma Linux, anything we can install. Once that base operating system is there, we then put that hypervisor. So that type 2 hypervisor can only help us achieve the desired result when it have that base operating system. So once that base operating system is there, on top of it, we install our hypervisor. Then again, voila, we have a physical device which can support multiple virtual applications, to be precise. So to make sure that we have multiple applications running on top of virtual machines, deploy onto the cloud, we need virtualization, we need hypervisor. Let me check if I think I missed anything, because like I told you, this topic is something which I can speak on and on and on, but I don't want to overwhelm you guys. So as long as it's part of syllabus, we cover it. If it's not part of syllabus, then I think it's okay to leave it, because this topic is never ending and I can speak on it whole day. So we should be covering cloud infra component, environment, network, compute. We are missing management plane. What is management plane? Everything we set up till now, our compute, our network equipment, our storage, our physical devices, everything need to be controlled. Everything need to be viewed from a single pane of glass. And if something goes wrong, or if we want to do day-to-day monitoring, if we want to have kind of like observability of the whole system, if we want to perform any changes in that system, we should be able to do it via single interface or via single connection. And that's what management plane is. So if we have a server on top of which we deployed application, those applications are connected via some backend networking device to the internet, and from internet end users are able to access those applications. Everything is absolutely fine. That is kind of like a data network where your real data is flowing, where your real application is sending data in and out. But that's not where the story ends. Someone have to manage that application as well. Someone have to manage that whole infrastructure as well. And for that, we need a management plane. We need a management interface. And that management plane or management interface is one of the key things which anyone have to make sure is there in place. Otherwise, any kind of issue if you are having, you have to go into the data center, plug in your laptop and do it on the site, which is not the kind of model we are building here. We are building a remote working model. We are working remotely these days. Anything goes wrong with your physical infrastructure, if there is a fire, there is no option. Someone have to go there and replace those hardware. But if there are basic day-to-day changes, if there is something wrong with the networking side, if someone is creating a new application and they are facing issues related to network configuration, they are facing issues related to their storage side, there is no need to go on site. There is no need to go into the data center and plug in your laptop and do the things. You should be able to do it remotely via some management network, some management interface. You can use inbuilt tools, or you can maybe purchase a different solution, a management solution which have in backend interfaces to your multiple infrastructure deployments. Maybe your front-end management application can have interface with your AWS setup, can have interface with your Azure, can have interface with your devices which are on-prem. But in front-end, in terms of user, you are just seeing a simple common management interface. And that's the idea behind using management plane, and that's the idea behind management interface. And it's really important. It's one of the things I don't think we covered it in chapter 1. So this is something new which we are covering today in this week's episode about management plane. Or I think we can replace it with control plane as well. Those two terms can be used interchangeably, or they can be having different types as well. So we can have a data channel, we can have a control channel, and we can have a management channel completely separate as well. It's all up on your design, but it's always there. It should be there so that you can manage everything without going yourself, without visiting the site yourself. And that's the idea behind cloud. We have to do everything remotely from our laptop. There's no need to go on site. There's no need to do anything physical. If you want to do anything, if you want to get a virtual machine, if you want to run an application, do it remotely from your laptop. Do it remotely from your own devices. Alright, that's it for this week's episode. For next week's episode, we'll be covering risk assessment analysis for cloud infrastructure. So now we are really slowly going into the cloud security topics where we are really securing that cloud infrastructure. So next week's topic will be really interesting. Make sure you tune into that and make sure you listen to that episode as well. Alright. Thanks for listening to today's episode. Goodbye and good luck.
Thank you for listening to Get Certified Together. If you loved our content, then please like and subscribe from your favorite podcast platform so you don't miss the notification for our next episodes and announcements.